So in this D Latch, we know that whenever the enable is 0, it will try to store the previous information. Basically, there is no change. And whenever the D is 1, it will try to set it, and whenever the D is 0, it will try to reset it. So we'll design this D Latch in the Logisim, and we'll see how to see the timing diagram of the D Latch. For that, let's get the gates. So I have this NAND gate. So you can just copy it, paste it, do the connections. Okay, so now connect this output node here. Of course, now it will be showing error initially because these values are quite undefined. You can name it as Q QB. So in the enable, we will be using clock, right? So we'll be using clock. So to use clock, you can go here in the wiring section and get the clock. So we'll connect a clock here. So name it as clock CLK. Duration of high, let's make it 5 tick, 5 tick, 5 ticks. We'll see what does it mean eventually. So again, for the input also, you'll use the same clock. We'll go for high and low. So yeah, but we'll have a different ticks for this one. So let's call it as, or let's write it as use use 3 ticks. Okay, 3 ticks. So 3 here. Okay. Label it maybe as D. Your input D. Okay. So now this is D and this is clock, but to run it you need to have one global clock which is just 1 tick. So this should be named as SYS CLK. So this is necessary to do the simulation. So system clocks. So basically this is the global clock. Okay. So, what it means is this is 1 tick, 1 tick. So this is 5 ticks, means it is after every 5 ticks of this system clock, this will be 1 tick, something like that. And this is like after every three ticks of the system clock, this will be 1 tick. So this is basically 3 times slower than this clock, and this is 5 times slower, which we'll see once we see the timing diagram. Okay, so the next thing for this, what we need to do is go to simulate. So we can see here, if you try to make the tick frequency, if you make it suppose 4 hertz, and if I just tick enable it, you can see that this clock is ticking, right? So this operation is happening, right? The system clock is ticking here, which is a little fast, but then these are slower, right? This is 3 times slower, this is 5 times slower.
Hello.
Okay, so now you can see that if you if you do that if you do the simulation and if you enable the tick, then you can see that this clock and everything is going up and down. So now, of course, we don't want to do it. It's very difficult to analyze this one with this. We want to see the actual timing diagram. So to do that, go to this chronogram. So when you open this chronogram, so you'll be asked to what all the waveforms that you would like to see. So first, we'll add this system clock. Of course, this will not be visible. We'll see that. This is just for the sake of reference. We want to see this output Q. We also want to see this output D, and we want to see the clock, right? So and timing timing frequency maybe just 1 hertz. Okay, so start the chronogram, right? So these are the different buttons here, right? So if we just hover around, you'll see that. So if I just press this, it will go one step with the system clock tick, and this is like start and stop, right? And this is just for simulating one step, and this is start and stop simulation, right? So if I just press this one step, right? If I click this one, the system clock is going by one tick, and we know that the our clock, it is 5 times slower, and the data is 3 times slower. So if I just keep on clicking, or if I just run it, right, then it will be continuously running. So now just stop it and see that whether this is happening or not. So this is my D input clock, right? So we know that for a D latch, whenever it is high, it is in transparent state, right? So my input is equal to output, you can see here. But whenever it is low, it is trying to store the this is Q, right? This is Q. So it is trying to store the information just previous to it. So you can see that this was high here, so just before the transition, so it stored this value, and so you can see it is high, and from here to here it has kept it high because it's just storing. So even if you see that D is changing here, but you can see that it's getting stored. So now after some time it goes to high, and it is in transparent state. So transparent state means whatever I have this D here, right, my Q is same, right? So you can try to do this analysis.